Students, now we are starting over a new topic, that is the interference in the sound waves. To study the interference in the sound waves, first of all we will discuss about the superposition and the interference. Basically, superposition can be defined as it is a phenomena in which the resultant wave is generated with the combination of the individual waves, and the displacement of the resultant wave is equals to the algebraic sum of the displacement of the individual waves. It is the superposition, and we know also that the interference is the particular type of the superposition in which we require the coherent sources. It is a basic condition for the interference. And what are the coherent sources? Coherent sources can generate the waves of constant frequency and the same phase difference. Okay, now we are generating here the sound waves by the two loudspeakers which are connected to the audio frequency generator, through which we can change the frequency of the generated sound waves, because the source of the waves is the same. Because the frequency is controlled by the audio frequency generator, it means the waves produced by these loudspeakers have the same frequency, and these waves are generated in the same medium, so these waves can interfere to each other. And we know that we have two types of the interferences. The one is called the constructive interference and the other one is called the destructive interference. If we discuss about the constructive interference in the transverse waves, when crust to crust or the trough to trough meets to each other, the constructive interference will occur, and these crust to crust and trough to trough will reinforce each other, and energy of the resultant wave will be increased. But in the destructive interference, crust will meet with the trough of the other wave and they will cancel out by each other, and the intensity of the energy of the resultant wave will be cancelled out, or it becomes zero. The same phenomena we can use to study the interference in the sound waves. Basically, sound waves are mechanical in nature and they are the longitudinal waves, and these waves are consisting on the compressions and the rarefactions. We are not showing here the compressions and rarefactions. We are showing here the wavefronts, and these wavefronts are corresponding to the compressions of the sound waves. For example, students, it is a wavefront which is corresponding to the compression, and it is the wavefront of the second wave which is generated from the lower loudspeaker, and it is corresponding to the compression. In between the two compressions, we have the portion of the rarefaction. Here also, in between the two compressions, we have the portion of rarefaction. Now, to study the interference in the longitudinal waves or the sound waves, we know that we have two types of the interferences. Number one, the constructive interference, and the destructive interference. Constructive interference will occur when the compression of one wave will meet with the compression of the other wave. Now the energy will reinforce by these two compressions, and the resultant wave have the maximum amplitude. Or if the rarefaction will meet with the rarefaction of the other wave, so they will reinforce each other and the resultant wave will be increased, and the energy of the resultant wave will be increased. And in the destructive interference, compression of one wave will meet with the rarefaction of the second wave, and they cancel out each other, and the energy will be minimized, or we cannot hear the sound where the destructive interference will occur. To observe the constructive and destructive interference in the sound waves, we have a particular line of action which is used as the screen on which we we have got the bright fringes and the dark fringes. Now here we are moving the detector of the sound waves on this line of action, and there will be the portions where the sound wave will be faint, and there will be the portions where the sound wave will increase its energy. For example, this compression and compression is meeting here. So corresponding to the middle point, we have the zero phase difference for the, or zero part difference for the incoming waves from the two loudspeakers. So we will get here the antinode portion because of the constructive interference, and the energy of the two waves will be reinforced in the resultant wave, and we will get a louder sound at the middle point. And here we will get a nodal position. What is the meaning of nodal position? It is a position where the crest to compression to rarefaction will meet to each other, and the energy will be cancelled out. So we cannot get the sound wave here. And if we move on this line of action in the forward direction, we will get another point where the energy will be reinforced because of the constructive interference, and we will get the loud sound at the point A again. And in the result of constructive and destructive interferences on this line of action, we will get the sequence of the louder sound and the faint sound. Due to the symmetry of this phenomena, we will get the sequence of antinodes and nodes, because antinode is the position where the energy is maximizing, and the nodal positions are the positions where the energy is cancelled out by each other. So we can define the constructive interference by the antinodal positions, and destructive interference by the nodal positions. So basically it is a phenomena of the interference in the sound waves. Thank you, students.